Okay, let's talk about inverse trig function, okay? So basically this problem, we need like one important technique. Okay, I will introduce like that technique with a right triangle, okay? But keep that in mind, all the sine and cosine function, sine, cosine, and tangent function, all trig function came from right triangle. So as long as you have like, correct right triangle with the correct dimension, then you can solve every single problem, okay? So, okay, another one. Like we use like arc cosine notation, okay? But like, it is same thing with cosine inverse, okay? But either way, it doesn't matter, okay? So let me introduce like one important technique, okay? So to solve this problem, we're gonna introduce new variable theta, okay? Let's say theta is equal to arc cosine of 4/5. Is it okay? So since I define theta as arc cosine of like 4/5, I can change my problem. Does it make sense? So this problem can be written by sine theta instead, okay? Does it make sense? So now we're gonna try to find sine theta, okay? My original problem is like too complicated, but like, if you can find sine theta, that's it. That is the answer, okay? So let me show you how we can do it, okay? So let me come back to this definition, okay? We define theta is equal to arc cosine 4/5. But like, do you remember the definition of inverse function? So by definition of the inverse function, we can say cosine theta is equal to 4/5, right? Since cosine and arc cosines are inverse functions, right? So that's why we can switch x and y. Is that okay? And this is definition of inverse function, okay? So with this one, like, do you remember how you can find cosine theta with the right triangle? I'm talking about SOHCAHTOA, right? It's from your high school, okay? So cosine is ka, right? Adjacent over hypotenuse, right? So we can say, like in the right triangle with this angle theta, 4 will be the adjacent side and 5 is hypotenuse side. Is it okay? So like, let me try to use this one like to draw the like right triangle, okay? Here we go. Right triangle. And let's assume this is theta, okay? As we find, like the adjacent is 4 and hypotenuse is 5, okay? So wait a minute, what about this side, which is opposite? Can you find it? Yes, you can do it by Pythagorean theorem, right? So this side will be the square root of hypotenuse square minus adjacent square, okay? So which is equal to square root of 25 minus 16, that is 9, and that is equal to 3. Does it make sense? Okay. So now let's try to focus on this right triangle. And can you find sine theta for this triangle? What is sine theta of this triangle? Which is opposite over hypotenuse, right? 3/5. Does it make sense? But you know what? I'm done. Because again, in the problem, we already changed the problem as sine theta, okay? Original like problem was a little bit complicated, but by define theta as arc cosine 4/5, I changed my problem into sine theta, right? And we find the correct triangle, then we can find sine theta from this right triangle, and I can say that is the correct answer for this problem, okay? It is a little bit tricky, right? But like, don't worry about it. Don't worry about it, okay? Because I'm gonna give you a couple more problems with this technique. Is it okay? Here we go. Another example with the same technique, okay? So we're gonna try to find sine of 2 sine inverse 3/5, right? But like again, sine inverse or arc sine they are same. Is that okay? But like the important thing is there is like 2 in front of a sine inverse, okay? That is torso, okay? So like, but like, first step is same. We're gonna define new variable theta, which is equal to sine inverse of 3/5. And with definition, and we can change the problem like this way. My original problem transformed like this way. Sine of 2 theta, okay? Wait a minute. Do you know like about sine 2 theta? And I would recommend to memorize this one. Sine 2 theta is double angle theorem, okay? So it is kind of formula. It is equal to 2 times sine theta times cosine theta. Is it okay? Now, like your complicated problem transform into this simple form. As long as you figure out sine theta and cosine theta, then you can find the answer. Okay, let's do it. Like let's start from here. Okay, because we have to construct like correct dimension right triangle. Right here we go. By the definition of sine inverse function, we can say sine theta is equal to 3/5. Is it okay? But okay, wait a minute. First of all, we already finished the first part. Dun, dun, dun. Is that okay? Then now let me come back. We have to construct a correct straight triangle, okay? So do you remember sine theta? I'm talking about, again, SOHCAHTOA, right? From high school, right? So since sine is opposite over hypotenuse, we can say 3 is the side of opposite and 5 is side of hypotenuse, okay? So with this idea, I can draw the right triangle here with angle theta, okay? Opposite is 3 and hypotenuse is 3, 5, right? Then, again, we can easily find your adjacent side, okay, by the Pythagorean theorem, which is 5 squared minus 3 squared, which is 25 minus 9. That is square root of 16, which is 4. Is it okay? Since we know all the dimension of your right triangle, it's really easy to find cosine theta. What is cosine theta then? Is equal to opposite 3 over hypotenuse. Oh, no. If you do like this way, it is wrong, okay? Cosine is adjacent over hypotenuse, okay? That's why your high school study is important, okay? Here we go. Then I'm gonna plug in this guy into my problem. Dun, dun, dun. Then we can finish this guy, right? It is equal to 2 times sine theta, which is 3/5, and cosine theta, 4/5. So your final answer is 24/25.